We can run, walk, swim, climb, but the one major thing we can't do is move around like the birds do.
5 kerosene-fueled microturbines, 1 exoskeleton suit, 1 oil trader turned obsessed inventor.
It's Richard Browning, the self-styled Iron Man.
The closest thing is like in a dream when you're flying around and floating about. My entire industry and my entire academic background has said for ages, doesn't work and won't be possible.
It's really encouraging what these hobbyists or citizen engineers are capable of doing.
In theory, you could fly down to the local shops, pick up a pint of milk and fly back again. We can take off secretly from an innocent-looking fishing boat a kilometre away, swarm attack the target from every direction.
It sounds like you are optimistic that we will reach the Jetsons era.
We will have military engagements taking place where suddenly one side will get absolutely annihilated because their clever, autonomous, networked mesh got jammed or got hacked. Human judgment on the ground saved the day.
What is it about the Chinese? Why do you think they will own the future?
Gosh, how do we compete in the West when we spend 3 or 4 years fighting government after government that just doesn't have enough time to plan or achieve anything? If we grow generations of kids that are grown up, well, everything's safe. That's not going to invent the next ChatGPT or the next Apple or the next Google or the next Amazon. If somebody magically comes up with a Tony Stark level of energy source,
Welcome back to Accelerate Bio. Today I am talking to Richard Browning, a real-life Ironman, founder of Gravity Industries and the man behind the jetsuit making human flight real. Hi, Richard.
Hi, nice to see you.
Nice to see you here. So let's jump right in. Human flight, it's one of the oldest myths. Why do we keep chasing it?
Yeah, it's a good question. So I think if you go back to our sort of metaphorical cave origins, as hunter-gatherer people, you imagine that was a pretty wild time to be around, and everything in the natural world must have freaked you out. Lightning, storms, wind, rain, everything. You probably came up with some, myriad of gods to imagine and explain. But during that crazy existence, imagine walking out of your cave or your hut and looking up and seeing the birds fly around and think, gosh, that is pure magic. How are they even doing that? And imagine the freedom and speed and just ability to go wherever you like in three-dimensional freedom. I do think that probably has a part of the essence of why we find it fascinating. And also, for everything that humans can do, we can run, walk, swim, climb, do all sorts of things. But the one major thing we can't do is step off the face of the earth and move around like the birds do. So I think it represents also just the ultimate in freedom and space to be able to just go where you like. I think it's a basket of all of those things, I think.
The ultimate frontier, which actually makes me curious, how different does the experience feel of using a jet suit than just flying inside of a plane or a helicopter?
Yeah, it's fundamentally different. So part of the original vision was, could you take a human being like you or I here, or like your audience, sitting there maybe listening to this or running or whatever, and could you add just a minimalist amount of technology to that human mind and body in order that you could step off the surface of the earth and fly around? And rather than sitting in a flight vehicle or being strapped to a large sort of flight piece of equipment, even like a hang glider, how close could you get to the idea of just adding that technology to you? So if you think about it, a bicycle, a surfboard, rollerblades, or a skateboard are all very small, pretty basic pieces of equipment, even a bicycle, and yet they magnify certain attributes of human capability in a magical way. So I thought, in the same flight vein, why don't we use the brain for balance, the body for the sort of structure, and why don't we try and arrange it in a way where as much of your natural human balance and stability is exploited. So the way you fly this equipment is, you've got engines on your arms and engines on your back. You form like a 3-legged tripod of thrust. And if you feel like you're going to fall to one side, what do you naturally do? You put your hand out to catch yourself. Well, now you're catching yourself with the thrust of these engines in a kind of effortless way that feels very similar to how you naturally respond to catching yourself if you're going to fall over. So the objective, I think, somewhat was achieved in that way. And it does feel entirely intuitive. When we train people, we've trained over, we've had over 1,000 people in the jet suit at various forms in the UK and US. Many of them learn to fly. And we've really noticed that they just don't get any skill fade. They don't they can go away for a year or a couple of years and come back, and it's as fresh as it was when they left before. So it really does feel as intuitive as walking or running. And when you're flying in three-dimensional space, there's nothing in your mind apart from, I'll just fly over there, and your mind and your body takes you. A little bit like a bicycle or running. You don't have to think consciously about very much. You just think, I'll cycle over there or I'll run over there. It's a very strange feeling. It's brilliant. It is the closest thing is like in a dream, when you're dreaming and flying around and floating about.
It's the ultimate human augmentation technology, isn't it?
I mean, I'm biased, but I'll take the suggestion. Yeah, in some ways.
Great. And let's jump back to the story of how gravity came to be. I know you told it many times, but what I'm really curious to hear is, when you were building the first prototype, was your mindset like, let's just experiment, tinker a little bit and see what happens? Or was it very like engineering driven, let's calculate what thrust we need? Or was it a mixture of both?
Yeah, so my whole family came from the world of aviation and engineering. So I had a reasonable background in understanding a lot of what was going on. I think that unlocked in me this realization that to a lot of people doesn't seem very intuitive, but to me it kind of was, which is that, a coffee jar sized jet engine blowing air out at 1,000 miles an hour that is on paper producing, let's say, 250 newtons, which is 25 kilos roughly, of thrust, is going to feel the same pushing as if I'm pushing my hand against some bathroom scales and it's registering 25 kilos. Or another way is, if I'm being supported by that, you could dangle 25 kilos over a pulley and hold the rope horizontally, and that pull towards it is going to feel like 25 kilos of pull, towards it. I think a lot of people think intuitively that, if you hold a jet engine and it's pushing out air, it's going to somehow rip your arm off. It's going to be just power and it's going to want to move. But actually, to me, it makes complete sense that a static force of 25 kilos pushing, just like, I'm sitting in a seat, you're sitting in a seat. If you tucked bathroom scales under your behind, you could register most of your body weight. I expect your legs are going to be on the floor, so there'll be some of your weight is removed. But the seat is thrusting you with 50 kilos of thrust upwards. If you swap that seat out for an engine that's blowing air out in a Newtonian matter type shotgun, pushing you the other way recoil manner, thrown a lot in there, then to me that just feels like that's the same thing. So if you can carry with you the device that is creating that force, well, I can go anywhere now. I don't have to sit on a seat. My seat is now being swapped out for a jet engine that is going to create that force. I think that was a bit of a leap, and that came from that background. I think I was a nice blend of, I did study engineering for a while, but then actually frankly got fed up with the maths and ended up going another route. I'm a very do learn, do get your hands dirty, try stuff kind of engineer. I can visually imagine things quite powerfully, I think. And, one of the first steps, and it's in the original TED Talk, the original 2017 main stage TED Talk, you can see that where I was holding a jet engine standing in a lane, so there's a country lane around not very far from here. And that first test was extremely informative because it not only validated what I just said about feeling like a static force, and if you ignored the noise with your headphones on, it just felt like a force. And importantly, there was no gyroscopic moment. So even though the turbine wheel's spinning at 120,000 RPM, when a car, usually is 7, and this is 120,000 RPM, there was no moment. So in other words, as you move your arm around, you didn't feel it fight you at all. And yet when you spin a bicycle wheel and try and move it, you can feel it fighting you. So a lot of people have said to me, there's no way they would have imagined that would have been the case. Well, if you get your hands dirty with a carefully managed experiment, it's amazing how that can unlock learnings you otherwise wouldn't get. So to answer your question, I've done it in a long-winded way. It's a mixture of background, intuition, and then experimentation, always with the rule, when it goes wrong, because it probably will if you're innovating, can you get back up again? You're not going to hurt anybody, go to prison, or run out of money. Those are my rules.
How many design iterations did it take until you achieved the first sustained flight?
Probably 100. But I mean, just to be clear, some people think you sort of build something, you get it ready, you go out, try and take off. and it doesn't work, and so you scrap it and then build another one. All of that is so wrong. In reality, I started with one engine, bench tested it like hell, got really clear on everything about how it worked, everything that was tricky about it, whatever, and then very gingerly got to the point of having it on an arm assembly and very low power, like made the discoveries I described. So then you go for 2 engines, and again, if you look for Richard Browning TED Talk, you can see all this. Then you go for an engine on each arm. Then you realize it's torquing your arms around. So you put one on the other side, so that balances the thrust out, and off you go. And you gradually iterate your way towards something that eventually flies. And it took me about 9 months alongside my day job to get to that point. But whilst you're doing that, you're also enhancing the way the control system works, the way you're housing the engines, the way you're managing the heat, all of these things. It's a myriad of parallel work streams, all of which are accelerating, getting stuck, deviating, stalling, failing, accelerating, succeeding, all in parallel. So it's a big soup of things, all like a horse race of lots of different horses, lots of different creatures, all running at different speeds. So it's not like you're just doing what I said at the beginning, one big experiment and then stopping and starting again. It's lots of overlapping experiments.
Sounds like a lot of fun and quite a process. And it actually makes me wonder, so you mentioned a little bit the technology, but just to double click on that, like what makes it possible now? Or like what is the reason that nobody else has perfected this before you?
Yeah, good question. And just to back to your point about fun, these journeys in hindsight are fun, but at the time are very frustrating because you do spend more time breaking and failing and wondering what you're doing. I did all of this with no knowledge whether it would actually turn into anything or not. Yes. So firstly, it's obviously I'm a small part of the journey, and it was my madness of disparate ideas pulling together to end up sort of getting into work. But actually, to be fair, it's entirely more down to the fact that these microjet engines, these little turbojets, the technology of those had accelerated like crazy in the last 20 years. So if you imagine the big engines that you have on a civil airliner, they are millions of dollars and take decades to evolve, luckily, and they're very reliable and enormous, entities that take thousands of people to come together. And that's good because that's why airline travel is so reliable and safe, and I spend a lot of time on airlines. I perceive that there will be many retirees from that world who in their free time then decided to take up model aircraft flying, started to adopt the challenge 20, 30 years ago. Can we build a little jet engine? Because it'd be much more cool than pretending with a little screaming internal combustion reciprocating engine in my look-like 747. And these folks just absolutely knocked it out of the park. They didn't have any rules. They just got on and iterated to the point where these little engines now, and they're being used in lots of other military applications, are so capable, they're amazing. And so it's their evolution, especially with self-contained microprocessor control to manage the thrust. They're just amazing. That's been the big breakthrough. So like I say, there's something the size of a coffee jar, a small waste paper basket can put out 20, 30, 40, 50 kilos of thrust and have all of its electronics and fuel pump and everything like that built into the cowling. That's insane. And even better, the ones we use now, you can press a button and within 20 seconds, they're ready to take off. I mean, that's nuts. From cold.
It's pretty amazing. That's pretty amazing.
So it's credit to a lot of the engineering and science and microprocessor control that went into those jet engines, which were not developed by Boeing, by Rolls-Royce and GE. If they were to produce those, they'd be $1 million each. Whereas, they've got them down to a few thousand now, which is amazing.
So are you saying these mini jet engines were developed by hobbyists for their own use, or you mentioned military as well?
They evolved really with hobbyists going, this looks hard to do, let's see if we can do it. And so they just brutally iterated over a couple of decades from a, Frank Whittle type mad thing where you'd have to warm it up with propane, monitor the RPM manually, stabilize it, swap it to kerosene without it stalling or over temping or over RPMing, get it stable, and then sort of start your, model aircraft. You'd get the electronics of the control system all ready. And then, 20 minutes later, you'd be ready to try and take off with this thing. Now you just press a button and it goes. So it's credit to what that community has done.
It's really encouraging what these hobbyist engineers or citizen engineers, whatever you want to call them, are capable of doing. I think SpaceX had a similar story. Elon recruited the first engineer out of some hobby rocket society. So it's pretty cool that this is possible.
I mean, there are so many examples. I mean, that one of the most famous is Einstein He was famously barred from joining or not invited to join, I think, the Vienna Physics Club because he wasn't from the right background. So he just worked by himself largely and came up with this, came up with everything he's come up with, where he had that magic blend of not being so immersed in the status quo thinking. If you do a triple PhD in aeronautical engineering and arrive, probably at my age, in your 40s, having been immersed in a career in Boeing, you're probably sadly quite unlikely to go and just throw that in the bin and go, I'm going to pursue something that my entire industry and my entire academic background has said for ages doesn't work and won't be possible. I've done talks all over the world where I've had even lovely professors stand up and after apologizing saying, this is ridiculous, this should never work. And you just flew it in my parking lot. I can see it does work. It's like, this shouldn't work. And it just shows nearly every technology breakthrough is impossible until it's not. It's such a stupid phrase, but it kind of makes sense. The idea of speaking to somebody on your iPhone or asking ChatGPT a question, those were impossible ideas 20 years ago, ChatGPT 10 years ago. So this is just another example of that. If you actually get out there and try stuff and iterate, it's amazing what you can actually achieve and that was supposed to be impossible.
By the way, if you're enjoying this, hit subscribe. We drop a new episode weekly, exploring how AI, biotech, and human enhancement are shaping the future. And if a friend would love this too, send it their way. It really helps us keep going. Now back to the pod. I think, AI and the current LLM architecture is another good example. I think when OpenAI started, all the experts and the academics were telling them, just applying scaling laws is madness. This is never going to work. And sometimes you just have to build it and prove them wrong.
But if you think about it, it's quite simple, really. Every major breakthrough in science or technology has gone against what the conventional thinking was, because if conventional thinking thought it was possible, they would be doing it. By definition, before the Wright brothers managed to get, powered flight going, it was considered impossible. Other than balloons and stuff and airships. And by definition, if the status quo thinking was that, well, no, it's definitely possible, they would be doing it. So I'm kind of comfortable with that kind of dynamic where if you're on a journey to do something quite breakthrough, by definition, don't bother asking everybody. They'll all tell you it's impossible. But that's how it is, right? If they said it was possible, then you're on a fairly already proven journey, or maybe something that's not worthwhile doing. So yeah, it's funny.
What gave you the courage, in this specific instance, to push through over those 9 months? And was it just a hunch, or was it something else?
Yeah, so I think it was a combination of things, conscious and unconscious. So I've had a career of doing unusual things. I have to say, I'm one of those annoying people when I see a rule set or a bunch of behaviors or a business or whatever, or a crowd doing something. I'm inclined to then not be interested. I'm interested in what the crowd isn't doing. And actually, if you take a step back, I think that's because, as somebody who was pretty dyslexic at school, I learned that my niche is not trying to do slightly better than everybody else, try and get 10 out of 10 in a test instead of 9 out of 10. It's actually to go and make my own test up that no one imagined. And most of the time, that's a waste of time. Most of the time, it fails. Most of the time, you're embarrassed. Most of the time, you are the lunatic. But just every now and then in my life, it's paid off. And I've got half a dozen occasions where it's paid off massively. I think having that behavior set, which, like I say, I've seen work out more, I work out just enough times to keep me on board with that behavior set. I think that's one thing. There's a slightly miserable family story, which it's in the TED Talk and the book and everything like that. There's a book on this whole thing called Taking on Gravity, if people are interested. And it's funny how nearly everybody in life, certainly in our team, their trajectory has been defined by something quite tough in their childhood. Nearly everybody I come across that's done something pretty unusual with their life, as I say, has had that adversity. And I think it either makes you stronger or it doesn't, and it damages you, and we don't get to choose. And I seem to have collected a team of people who just about have let them make it stronger. My father was a maverick inventor, creator, designer, engineer, but he got relentlessly screwed over. He actually invented mountain bike suspension, of all things. And then the industry kind of overtook him and took him for a ride in a big time. And he took his own life when I was 15. So I lived around an entrepreneurial journey, and I witnessed all the excitement of the possibility and the, we're so close to making it in a big way and having a big successful company. And then I just saw it just gradually die, ultimately, in every sense. So I think I'm driven subconsciously, and I've not been aware of this until the last decade, I'd say. I'm driven by this burning desire to take seemingly marginally possible challenges and try and make them good, because it's sort of undoing that, childhood experience. That's my interpretation of me. Like I say, I think that kind of drive, unusual drive, allows you to overcome the relentless setbacks. There was weeks and weeks and weeks where I would work really long hours in London on my day job. I'd stay up all night trying to build the next prototype. I would get there on Saturday morning. I'd get to this farmyard, drag my family out to go and do it. And then there'd be a puff of smoke. One of the speed controllers had shorted out, and I'd have to pack it all away for an hour. Nothing. Done. So I'd then have to pick myself up, having wasted all that time doing something that might never work. And I'd have to rebuild it over the next week. And then I'd go out again, and then it would happen again. And then you just start to think, am I completely insane? And that is tough. You have to just cling to the idea that you're hopefully just getting through the failures that will eventually get to the breakthrough, or the point you pivot to another direction. And that's hard to judge which that is.
Thank you for sharing that. And I think those traits are very commonly shared amongst founders. So it makes a lot of sense. Yeah. So back to the company for a second. You mentioned the origin story. You said now it has grown to become $100 million enterprise, I think you said. So that makes me curious, where are we at when it comes to the adoption of this technology from like the hobby spectrum to like mainstream adoption? Where are we at?
Yeah, so, firstly, the disappointing thing to share is that I don't think anytime soon we're going to see sort of personal jetpacks or jet suits or personal flight systems like this. I think the air taxi world will eventually become quite a big thing, probably driven by China, and we'll limp along behind afterwards, I think, in the West. But the flight system now, if it was one sitting here now, I could put it on. My record is sitting next to it. I can put it on and be in the air in 36 seconds. And then to keep the math simple, if you hit 60 kilometers an hour, which you can do in a second, you can be a kilometer every minute from in any direction. That sounds great. But, in theory, you could fly down to the local shops, pick up a pint of milk and fly back again. You could fly to a petrol station, gas station. You could refuel it with diesel. You can fly on diesel if you want. But all of this is ridiculous. This is as practical as taking a Formula One car to the shops. It's like, yes, it's a car and it would drive you to the shops, but for every obvious reasons, it's very loud. It's pretty over spec, potentially very dangerous if you're not careful with it, and just the wrong tool for the job. So we've got a bunch of niche military and medic applications. We do racing. We've done 400 events in 52 countries. So it's got lots of niche applications, but it's not getting to the stage where it's going to be a sensible way of people traveling around for now. But the first motor cars were considered noisy, crazy, dangerous, and not practical. So look how that kind of evolved. So I'm 70% can't see it happening, 30% open-minded that you never say never.
You said for now, and I'm very interested to double click on that. What would need to happen for that to change?
So we built an electric version, which are just electric ducted fans and lithium batteries. But as everybody probably is fairly familiar, the per kilo energy density of lithium batteries is terrible compared to gasoline or diesel or jet fuel. So it only flew for about 30 seconds. The batteries weighed nearly more than the pilot. It was quite terrifying because if those batteries had a problem, you've got to get out really quick. It's much more dangerous than jet fuel, which is very similar to diesel. Everybody thinks it's terrifying, but it's like diesel. I mean, it's very hard to actually ignite. So to answer your question, if somebody magically comes up with, frankly, a Tony Stark level of energy source, his magic glowing thing in his chest or whatever, some sort of very benign, safe, hugely lightweight, it's not a contradiction in terms, very lightweight energy source that could power those ducted fans and avoid about 50 kilos of batteries, then you could make the fans much smaller because you're carrying much less weight. And then you probably could. You could have a control system that pings the ground and says, I'm only, a meter off the ground and I'm not going to let you go higher than that. So the safety is pretty good. You could have an airbag system in case you failed, but it's a mountain bike level of crash, that's how we tend to fly anyway. So maybe then you could, but then it's going to be like a Lime bike kind of scooter because you're going to want to very quickly have a roof. and keep out the rain, and then you've got to have some sort of crazy air traffic control system to keep people. I don't know. There's lots of challenges. Never say never, but it would be the main answer to your question as to why not is that energy density. I think because the electric system is a lot quieter and obviously more sustainable. We can run biodiesel and biojet, but it would be more sensible if it was electric. I think it's the electric energy source.
So we need some super miniaturized lightweight batteries.
Which, to be fair, the whole world is desperate for, and there's billions of dollars going into it all the time, so I'm sure we'll get there.
It's fair. And so in the meantime, you're saying military use, mountain rescue. What makes it good for this? What makes it useful for the military?
Yeah, so you can... and it's not obvious to people who haven't got military experience. You kind of think it should have guns and you should be flying around like some sort of Marvel superhero. If you think about it, a big part of military operations for special forces is mobility. In other words, I need to get somewhere, do a job, and then importantly, get away again really efficiently. Often that's helicopters or walking quietly in, and then it goes loud because you're doing your stuff, and then you want to get out really quick, but the helicopters don't want to come in because they're now a target. So the really obvious one is maritime boarding. So if you've got to get onto a ship because it's been taken hostage by terrorists or whatever, then the only ways at the moment are fast roping from a helicopter, which is a very easy target, and they don't like doing it because they can hit the rigging, and you're dangling a bunch of people one by one down a rope, and they can let go and Black Hawk Down style hit the ground and all this sort of stuff. So that's not great. And the other option is you come up with a boat and you hook a pole, 20, 30 meter pole, usually not more than 20 meters. And then you hook a caving ladder, and then you climb a caving ladder fist over fist, banging on the side of a moving boat. It's terrible. You're very vulnerable. You can't really do much to defend yourself. If they spot you, you're in trouble. If you fall back in the boat, you can hurt yourself. If you fall off, you can get sucked under the ship, all that sort of stuff. So we can take off secretly from a innocent-looking fishing boat a kilometre away, swarm attack the target from every direction. You actually can't hear it in a maritime environment. It doesn't sound likely for people who've heard how loud our system is, but the noise disappears. And then within seconds, and you can see this on Gravity Industries YouTube, I think it's the most viewed film there, the Royal Marines exercise. It's like 40 million views or something. You can pop over the deck and land and then have a weapon out. You can have a helmet-steered weapon. We've got that as well. And you can swarm immediately, superhero style, all over the target. And if you decide you want to go away again, you can self-extract or relocate on the target. And we've essentially delivered the same thing in hundreds of locations all over the world to get in, deliver a job, and self-extract. That's really the essence of what we can do. You can fly below anti-aircraft systems. You can fly below drone countermeasure systems. You can fly below the terrain level, over minefields, over wire, over water. We even operated in Ukraine for a little bit. And it's a pretty miraculous capability for the right job. And so in the same way, for mountain rescue, if somebody's got a time critical problem like a heart attack or a bleeding out climbing wound, from falling off climbing or something, or breathing difficulties, asthma attack, we've flown up mountains that take an hour and a half to 2 hours for people to walk up. And we've done that in 2 or 3 minutes. Again, it's all over the Gravity Industries YouTube. And we've operated in many conditions where normal mountain rescue helicopters can't operate. It's a sort of superhero capability of whipping up a mountain really quick and getting to the side of the casualty to support them while the cavalry arrive when you bought yourself a couple of hours.
Everybody loves some good superhero capabilities, but it also makes me think, is the future of the military this kind of human augmentation, or is it unmanned drones?
Yeah, so you might think the drones just remove all this completely, but in the same way, the future is looking like, a super expensive fancy F-35 with a pilot in it, actually with a bunch of loyal wingmen, drone jet fighters following and doing the dangerous stuff. We've done a lot of exercises with special forces where we allow a special forces team to keep up with the drones, because especially in a medic environment, but also if you're collecting intelligence, if you've got to make a judgment call when you get on target, if you've got to adapt to the situation, if you've got to speak to the hostage, you've got to recover the intelligence, you've got to place the explosives in the right place to do it sensitively or whatever. There's a myriad of reasons why special forces still exist and pilots still exist. And that's because the human judgment call that can't be jammed or intercepted or messed with, having that at the front line to make that specialist judgment call and decision, especially when the circumstance change. I was Royal Marines for 6 years or so. they do tend to change against the plan. That is really valuable. Medic example, somebody's got an asthma attack or a heart attack. Do you want a robot to land next to you and start talking to you and trying to roll you over and get you on a stretcher and see if you're okay and inject you? And no thanks. You want a human to be there to talk to you, make the assessment, and then stretcherize you. And then the drone comes in and lifts you and takes you away. In the same way with the military, why don't you fly like an aircraft carrier group with the four-man special forces team surrounded by fire support, recon and heavy equipment behind you? So it's about teaming with drones. We allow special forces and medics to work with drones and be about as nimble and as mobile as the drones are.
So we still need human judgment and human engagement on the ground, on the front line, not just removed looking through sensors from
Yes, I think so for the foreseeable future, for the next couple of decades anyway. And also in the next couple of decades, I absolutely guarantee you, we will have military engagement scenarios going on in the world. And I mean, let's be clear, I wish they weren't going on, but it seems like the world's getting a more angry place. We will have military engagements taking place where suddenly one side will get absolutely annihilated because their clever, autonomous, networked mesh swarm system of air, sea, and land that was all speaking as one got jammed or got hacked, right? I remember an amazing story when we were in Ukraine. There was a period where both sides were using Mavics and the landing light button was rewired to drop a grenade. Horrible scenario, frankly. And this is the story I heard, which I believe is true. The other side managed to hack the push out mandatory DJI update. And they hacked it to make the update go out without asking any of the users, and they pushed this to the Ukrainian side. And the update meant that when you lift your grenade, fly to your destination, when you press the landing light to drop the grenade, it doesn't drop the grenade. It goes precisely back to its launch point and then drops the grenade. So for a horrible couple of weeks, the poor Ukrainians, I believe, were finding their drones coming back and then dropping the grenades back on where they'd launched. I mean, the genius of that is amazing. That's a tiny insight to what's going to happen when you're smugly thinking, probably as the West, you've got an amazingly integrated system, and then the metaphorical batteries run out and the whole thing fails or worse, turns on you. Whereas if you've got humans in the loop that are actually making the ultimate decision, there's too many military examples out there of where actually human judgment on the ground saved the day. So we support that, as in our equipment supports that. But give it 20, 30 years and there'll probably be no humans involved in any of this.
What you described is basically a slightly different twist on the Skynet nightmare scenario.
Yeah. I mean, yes, that's a whole separate subject, isn't it? We're all as a society agonizing slightly with worrying about Terminator 2 scenarios or whether they're just going to make all our lives easier and better. Who knows? That's a bigger subject.
Okay, we can get back to that later, but so talking about the use cases, you mentioned the military, the Navy use videos. I've seen them on YouTube. I think one of those clips had actually over 100 million views right now, if I'm not mistaken, which is amazing. That just tells you how much this, how visceral this resonates with people when they see this. They're like, oh shit, this is really cool. And I guess that ties into the other use case that you mentioned, which is these races, these spectacles. Is how is that looking? How much traction are you getting with that?
So again, on the Gravity Industries YouTube, there is a really cool race film. That's done 1.5 million views, and we never even promoted it. So that's pretty cool. Every time we've done an event around the world, we have, I think, fair to say, left audiences pretty dazzled. The first time you see it live, and there's bound to be people listening to this that will have seen it live. It genuinely, and obviously I'm biased, but it genuinely is one of the most mad things you'll ever see. It does not look real. Your brain refuses to compute. You're seeing a human move around. You can't really see much of the equipment and the legs are dangling. And it's like, how that's got to be fake. And yet it's right in front of you. In fact, as a side note, in this now AI world, if I'd launched the company now, I think I would have had a challenge because everybody would have just assumed it was AI. But anyway, because we had lots of people for about a year thinking it was fake even back then in 2017. So we used to dazzle audiences, and then even the pilots and I would be like, gosh, this is so fun when you've got several pilots in the air. Imagine doing it over water. So if you screw it up, you just fall in the water and it floats, and it's a bit expensive, but it's okay. Wouldn't it be cool just to see how fast you can go? Because when you put humans together in around a racetrack or whatever, everything kind of, you really experience the limits. So with the support of Dubai, a great place to do it, home of everything crazy, mostly in a good way, then we put it on and it was epic. It was so fun. The challenge is, and it's boring this, but the challenge is that it's actually quite hard to make money out of sports. I'm sure, again, people listening to this can think of football teams, golf franchises, tennis tournaments, you name it, even motor racing, even Formula One was struggling before Drive to Survive. It's very hard to actually make sustainable revenue out of most sports. There's only a tiny number that really take most of the revenue. So I was very aware of that. We actually broke even on putting that race on that you can see online, and it was epic, and it just got rave reviews and everybody loved it. I suppose the challenge is, as the CEO of this company, I am the owner of what do we spend our time on. And as you've heard, military, medic, doing events, training clients here and in California, we've got a lot going on. We could easily be guilty of just throwing all of our resources to have, 20 suits and, 10 pilots and amazing, exciting visuals. And it would be a right expensive circus. And then a couple of years later, we go, hang on, why have we got no money left? We've had a wonderful time. And that's what I'm the guardian of, if you like. So we have a project running now, taking the learnings and lessons from Dubai and building what we think will be a really successful franchise. But it's ring fenced so it can live or die on its own basis, because I don't want it to drag the company down. That's the long-winded answer to why we're not running it all the time. But my vision is it'll tour around the world and inspire, all sorts of people, and any companies that get involved with it have a really authentic manifestation of what it means to innovate and be an entrepreneur and push boundaries and rise above and all these good things. We really manifest that. We've worked with lots of big brands in the past, like Google and stuff. So it should be cool.
It does seem like you're really onto something there, based on those reactions.
Yeah, and also it's very social media friendly. Again, just look at our Instagram. That if you look at Take on Gravity, like we're fighting it, Take on Gravity on Instagram. We've got clips that have done hundreds of millions of views on there. To be honest, it's kind of a fun problem, but we've got so many different avenues we could go. We've got to be really clever on what we spend our time and money on to keep this show on the road. There are lots of people nowadays that will invent something crazy, put it on YouTube. They'll be around for 6 months, do a few TV interviews, and then it dies. Because actually the bigger challenge is not inventing the thing so much. It's actually working out, how do you brand it? How do you market it? What do you want the audience and companies and sponsors, investors and the press, particularly, the media, to actually think of you of? So in the UK, I was terrified of the idea of them instantly going, look, mad British inventor blowing himself up in this garage, haha, very funny, and then just move on. How am I ever going to get a military engagement if that's the public perception? So we had to work very hard, and we did it with Wired and Red Bull as two really good brands. How do we position it from day one as something admirable, aspirational, superhero-y in a non-childish way? Americans don't have a problem with that, but the rest of us and the rest of the world look at superhero stuff and think, oh, it's a bit childish. Anyway, that's been the main effort in the first few years of trying to position it in the right way. So I don't lose sight of that. I could get it all wrong 9 years later and just throw everything at the race series, and 2 years later run out of money. Whereas as we're going, we're doing really well.
So talking about focus, priorities, and impact, if we fast forward 20 years from now, what do you think will have been the most important thing Gravity will have achieved?
I'd like to think, and we do get lots of letters from people, and we do get lovely messages on social media, and it's quite nice. We don't really get much negativity at all. I do think it is that really unexpected, unintended opportunity to inspire people. We were the biggest activation at Oshkosh, the biggest air show, really, one of the biggest air shows in the world. And we were just flying the flight line twice a day. The Raptor team were waiting for our cue to launch. It's ridiculous, the F-22s. It was a mad thing. But as a case in point, and our stand was packed out of every demographic, from 7-year-olds through to retirees. And all of them were the same. They were like, this is my childhood dream. This is like Iron Man brought to life, or the Rocketeer, or, I've had amazing messages from students who saw us at an event in their, early teens, and they've written and said the sole reason they've gone into engineering is because they saw us at an event. That's pretty cool. And I'm actually, as a side project, I'm actually trying to experiment with using the company, and I suppose me as the figurehead of that, as a representation, hopefully an authentic representation that has worked in corporates, in government, in military, and several startups now, to try and bring to life what real innovation and entrepreneurship actually means. I feel like innovation and entrepreneurship, they're two quite long, fussy words that are thrown around cheaply by governments and corporations and leaders without often having done that, right? Having actually walked that walk. And yet I think innovation, the failure-ridden process of inventing something, building something from a crazy idea, childish idea sometimes, through to a breakthrough that employs thousands of people. This isn't us, but we're getting there. That makes people's lives better and creates an export industry. That's a really important process, right? That's built our modern world. Entrepreneurship is then commercializing that and turning it into something that makes more money than it costs to do and puts tax revenues into the coffers of our, indebted governments. If we don't rediscover this, we haven't got a hope of, a prosperous future and employing our children. So I'm trying to use this again, long answer, but I would love people to look back at Gravity and think, wow, that was an amazing little milestone in the Wright brothers family tree of flight. We're a tiny little part of that journey, but also it reminded the world of actually what it means to innovate and be an entrepreneur. That would be super proud.
That's a very important thing to unlock. Getting more people excited about entrepreneurship and engineering, and especially the tinkering. Let's just do it. Let's just not listen to the expert's mindset that is said in the beginning.
I completely agree. And I think everybody, you and everybody listening to this, I think would agree that we've been on an understandable sort of risk-averse 20, 30 years, right? Every time somebody has an accident, understandably, they put in a load of prices, a load of rules to try and desperately avoid that happening again, let alone if somebody's killed, and everything from seatbelts to handrails to high-vis to hard hats. Brilliant, right? We've been on a journey. It's almost politically incorrect for me to say this, but there's a price to this. If we grow generations of kids that are grown up where, well, everything's safe, and if something goes wrong, just immediately blame somebody, and that's wrong, and life is about everything should be perfect and safe and fine, and you just sue people and write to the newspapers if something goes wrong and shame them on social media. We've lost sight of actually risk and failure. As long as it's recoverable, as long as you can get back up again from that safety, reputation, and financial perspective, risk and failure are the lifeblood of innovation. Mollycoddled, risk-averse children that are taught to follow the Lego instructions and chastised, punished for getting it wrong, and then take it apart, put it back in the box, put it on the shelf. That's not going to invent the next ChatGPT or the next Apple or the next Google, or the next Amazon. We've got to rediscover, frankly, what the Chinese are embracing in their 20, 30-year journey they're on. And that is that messy discovery, childlike process before you batter them into school of learning and discovering and getting things wrong. But anyway, it's a bigger debate, but I'm trying to craft a narrative around how to just gently shine a light on this mission critical ethos of innovation and entrepreneurship. If we don't get hold of them again, we're not going to be in Europe generally. We're not going to be enjoying much of a prosperous future.
So you mentioned the Chinese twice now, and that makes me wonder, what is it about the Chinese that makes them successful at engineering hardware? And in your eyes, why do you think they will own the aerial vehicle space in the future?
Yeah, if you go to Shanghai or Beijing, I haven't been for a while, but you go there and it makes the rest of the cities in the world feel like we're 100 years behind. It's shocking, right? I'm not condoning the Chinese sort of communist management system of the country. I think that's got some major downsides, but you know what? Their ability to do long-term planning and say, right, in the next 10 years, we'll be the leader in solar. Right, let's go mobilize. Oh, look, we can clean up our cities with the horrible pollution they used to have 10 years ago. Let's just really push ahead with electric cars. Let's state sponsor it. Let's be the world leader and then export them and then make billions and trillions out of that. Gosh, how do we compete in the West when we spend 3 or 4 years fighting government after government that just hasn't have enough time to plan or achieve anything? That's tough. But no, I think the better answer to your question is if you're a young person working in an Apple factory, maybe bad example because that gets bad press as well, but you're working in a tech firm, you can probably remember visiting your grandparents in a little rural village where they had a pig on a string, and their parents probably went through several famines. There's nothing like, we talked about adversity, we talked about childhood adversity. There's nothing like the galvanizing power of knowing what you've come from that was tough, and then being determined to build and grow and fail and innovate your way to a better future. We've got the opposite in some parts of, the West, where, your parents had it really easy. They gave you everything as a kid. The living memory of the war is several generations back. You feel like as you grow up as a kid, you can't really achieve anything like what your parents have done. You've got it all on a plate. Doesn't feel like there's any real downside. I'll just game, social media, indulge my way through to my deathbed. Sod it. Why should I bother? I have no stick or carrot. I have no fear of the downside. I'm not that excited about the upside. Why bother? That malaise, that is a problem in countries that have enjoyed a profitable 30, 40 years. China hasn't had that. China's enjoying it now. The next 2 or 3 generations will have exactly this problem, and it'll go in a cycle. That's the reality of life, it seems. There's the phrase, tough times breed tough people breed soft times breed soft people breed soft times, which breeds hard times. There's a horrible, annoying cycle.
I agree with you, unfortunately, and I think you hit the nail on the head. There seems to be a lot of nihilism in the West right now. People not being very optimistic about the future at all. But just to flip that back at you, it sounds like you are optimistic that we will reach the Jetsons era in the West, that we will continue on this path of progress, or maybe rather, what do you think do we need to unlock to get back on the track if we're not certain that's the way?
The best I've come up with so far, and this is behind this mission. I mean, there's a petition out, a UK petition that I've launched just as one of a series of things that are going to happen in the next 6 months to try and make a point. I'm petitioning the government to include business and entrepreneurship as part of the national curriculum. How mad is it that you can leave school in the UK with more knowledge about Pythagoras and Shakespeare? Again, I'm not dishing them, brilliant. But working out the hypotenuse of a triangle versus absolutely no understanding of a tax return, how to patent something, how to register a company at Companies House. Nearly everybody leaves school and eventually goes in some form of business, and yet school doesn't prepare you very much for that at all, let alone entrepreneurship and innovation. And it's not about teaching those, it's just raising awareness that they exist and what are the behaviors around them. So there's a lot to do there. I am optimistic that I think we'll get there, because I feel like in the West, in Europe and the UK, we are gradually seeing the writing on the wall of actually our governments are indebted. AI is disrupting our kids' jobs. We've got ever increasing national debt. I'm not so convinced our jobs are still there. That's going to gradually build the tough times that will build people back into tougher people to get this sorted. It's a cycle. And if I can use gravity and I can use the story of that as a very visual, powerful manifestation of the spirit we need more of, I think, then if I can shift the needle a few percent, then that will be my task done. If I can get a few people to actually recognize that as the behavior set that unlocks this, a few more people, not just being innovators, it's more the people who are not inclined that way, that it's so easy, they find it so easy to kill opportunities. You're a middle manager in a government or a big company, and some new graduate or new starter says, look, I know you've already always done it like this, but what if we just did this, that, and the other? I think it might save some time. The inclination we're taught in school and university and big companies is to go, oh, that's new and different, scary. It might go wrong, so no. And yet, if we just have a few more people who just pause for a minute and go, it's one of those innovation things, isn't it? Ooh, it makes me feel uncomfortable. But if I put a fence around it and allow you to fail without hurting anybody losing their jobs and us running out of money, spending too much money on it, go, do it. Because idea 20 like that might change the world. That's how every company and product has emerged. Anyway, that's my mission, to try and better remind people that's what it takes. So I am optimistic we can do something about it. I just want people to be slightly more glass half full. I think that's going to change the world if we can channel that spirit.
We should all be slightly more glass full. That's a good parting thought. Thank you for your time, Richard. This has been great.
My pleasure. Lovely to talk to you.